Mr. Jones. Oh, there he is. Mr. Jones. Oh, yeah. Mr. Jones. There is he. Mr. Jones is math with Mr. Jones.
All right. Good morning, ladies and gentlemen. Today we're going to talk about the testing strategy or our STAAR strategy for today, which is known as guess and check. Guess and check, also known as plug and chug, also known as see and find out, also known as trial and error. It's known by a lot of names, but the strategy itself is one of the most common used strategies in mathematics. And it actually allows us to have a lot of success on problems when they are multiple choice and we are struggling with either our ability to remember a skill or if we're struggling with being able to work out the problem with the skill that is given to us. So here I have 5 problems that we're going to work out together today, and we're going to utilize our guess and check method. Without further ado, we're going to go ahead and dive right into our problems here, and we're going to take a look at this first problem. A teacher bought sets of books at a cost of $17.95 per set. The teacher also paid a one-time shipping fee of $22. Which table shows the relationship between the total cost of the books and the number of set of books the teacher bought? So first off, there's a lot of information going on in this problem, so I'm going to go ahead and utilize my cubes method to bring down the amount of information that is going on. So the first thing that I'm going to do is I'm going to go ahead and circle all of my numbers. We have $17.95 per set. We have a one-time shipping fee of $22. And we know that the table is showing a relationship between the total costs. We're going to go ahead and underline our question, which is which table shows the relationship between the total cost of the number of books and the number of sets of books the teacher bought. Now, the next one is to box any of our key words. So when we're taking a look here, words that are key to what we are taking care of here, things like per set. The teacher also paid a one-time shipping fee. Put a box around that, not a circle. There we go. And then we're looking for the total cost. So when working through this problem, things that we should understand is that every single book costs $17.95. And I pay one time $22 extra. So what we want to do is we want to work through our math to figure out which one of these I can, since it says per set, multiply by $17.95 and then add, going to multiply, change my colors here, by $17.95, and then because I paid a one-time shipping fee, we're going to add that extra $22 to it. So when we look at our answer choices down here, we notice some things that are similar going through it. Each and every problem starts off with 16, 20, 24, 28 books. And the difference is the amount of total dollars. We have one that says $746, $369, $682, $309. So the good news is every single one of these are different. So I know if I solve for one set of books, I should be fine with all of the sets of books, okay? The next thing I'm going to do when I work this problem is I notice that none of these answers are really close to each other, so I don't need to use an exact dollar amount. So for those of us who do not use a calculator, this problem can be done a little bit easier. But what we're going to do is we're going to take our $17.95 and we're simply going to make that $18. And then we will multiply that times the amount of books that they are purchasing, which is, we'll go ahead and start off with, I could do 16, but I'm going to show you guys a better strategy, and I'm going to go with the number 20. The reason why I'm going with the number 20 instead of 16 is because it's easier to multiply by hand. I can multiply by 20 a whole lot faster than I can multiply by 16. When I multiply by 20, I get to bring down to 0, multiply 2 times 18, which gives us 36. And that tells me that for 16 books, it's going to cost approximately $360. It's going to be a little bit less than that, but it's going to be very, very close to that. And then we also have a one-time shipping fee of $22. So we will go ahead and add the $22 to this. And when we add the $22 to our total price here, we wind up with about $382. So we're looking for the answer for 20 books. That is going to be the closest to $382. 457 is a little high. 753 is way too high. Way too high. This one seems close enough. So out of all the problems that we worked out, this problem is the best answer. It is the closest, and I did not have to use all those decimals to be able to work out my problem. I plugged in a number, I estimated my numbers, and then I used a little bit of math to solve. Let's try a new problem. But we can once again break down some good information. They don't give us any type of numbers in the actual word problem, but they do give us a graph, and graphs will always give us our numbers. We have time and we have feet. So there is a relationship happening between the time and the feet in this well drilling. And luckily, since this is a coordinate grid, we can call every single point on this graph x, comma, y. So because it is x, comma, y, the simple things that we're going to do is we're going to find at least 1 or 2 points on our graph here. And we're going to use it to plug and chug into these equations down here. So we need 1 or 2 points, and then we're going to plug and chug or plug them into our equations down here and figure out which one gives us exactly what we are looking for. So 1 or 2 points. The easiest point here is 0, 0. Do I really want to use that? I could. So I'm going to go ahead and teach you, yes, anytime they give you 0, 0, use it. But now I need to find one more point that is exact in this information. Let me zoom in a little bit, glitching a little bit. We're fine. So I'm going to follow my points. Don't like it, don't like it, don't like it, don't like it. Ooh, I like that point. Kind of like that point. It gives me 2.5. Ooh, I like this point better. So this is a fantastic point because I know this is the point 5 and 30. 5 is my x and 30 is my y. So for one of these equations down here, we can plug in the numbers 5 and 30 and get our solution. And we can plug in the number 0 and 0 and we can get our solution. So I'm going to go ahead and pause for a moment and give you a chance to plug these in for X and Y for each of these. Well, I guess I should give you the first example. That would be mean for me to go ahead and pause now. Let me show you one example. So we're going to plug that in for the first time, and I'm going to plug in 0. So my X is 0. My X here is 0. So I plug in 0 here and get 6 times 0. And my Y is 0, and I want to see, is this true? Does 0 equal 6 times 0? And the answer is yes. That works out well. But don't get too excited yet, because that also works for this one. If I plug in 0 for my X, I get 30 times 0 is equal to 0. And this says that 0 is also equal to 0. So far, these two answers are fantastic. When I go down to problem C and I plug in 0 and 0, I wind up with 0 is equal to 5 times 0 plus 30. Once again, I plugged in 0 for X, and I plugged in 0 for Y. And I found out that 5 times 0 is 0, and 0 plus 30 is 30. So this does not work. And in this problem, we're also multiplying by 0 and adding 30, so I can go ahead and assume that that does not work either. So because 0, 0 worked for A and B, we are now down to 2 answer choices. But luckily, we found a second point to plug in, which was the point 5, 30. So go ahead, and now I'm going to pause for a moment, and I'm going to give you an opportunity to substitute in 5 for X and 30 for Y and figure out which one works. So this is when you're actually substituting. This is when you're actually substituting. Good news is I can edit this part out. They were plugging in 5 and 30 into A and B. One of them works, one of them doesn't work. It's difficult to see from that corner. I would suggest sitting here. So for those of us who took the time out to plug these numbers in for A and B, since C did not work, we had A is equal to, or the answer A, we have Y is equal to 6X. So we go ahead and plug in 30 for Y, and we plug in 5 for X, and we find out that 6 times 5 is 30. The other side is 30, and because in algebra we want everything to be equal to each other, both sides are the same, so the only solution here that works is A. If you're like me and you don't trust it, you're more than welcome to plug it in for B and say that 30 is equal to 30 times 5. 30 times 5 is 150. 30 is 30. And that does not work. They are not the same. So B is not a good answer. So we have simply plugged in every single option and we found the one that works every single time. Let's try another one. A list of numbers ordered from least value to greatest value is shown. One number is missing. Which number could be the missing number? Now, the bad news, good news situation of this is that each of these numbers are put into different forms. So we have to change these into normal numbers. For 8th grade and algebra, for a question like this, you have a calculator. So you get an opportunity to plug each of these into your calculator and to change this into the other form. Without a calculator, we have to do these by hand, but that's fine. We can simply do that. Let's see here. 18 over 5. 5 goes into 18 3 times. And then we're left with 3 over 5, which is 0.6. This number already is 3.71. And then the square root of 17 is between the square root of 16 and the square root of 25, which means it's between the number 4 and 5, which means it is slightly bigger than 4. So we can approximate this to be about 4.1-ish. That works out well. Now, I'm looking for the number that's going to fit in between 3.71 and 4.1. Now, the first answer that comes to mind, that is going to be the one that I'm probably going to circle, that most students will circle, is going to be out of B and D. The problem is that neither of those answers are correct. Let's go ahead and see why. Percent means out of 100. So 3.8% means how much is this number out of 100? So we have to take 3.8% and we want to multiply that or divide it by 100. That's a good question.
If you multiply, it'll be 3,800.
And let's start with C. We'll come back to the percent. My brain's blanking. It's first thing in the morning. So 57 divided by 15 leaves me with 3, remainder 12 over 15. 12 over 15 simplifies to 4 over 5, which gives me 3.8. Ooh, that sounds fantastic. 3.9 squared means that I am multiplying approximately 4 times 4, which is close to 16. That is way too big of a number. 4.5 is way too big of a number. We've already proven that C works. 3.8 as a percent turns out to be the number because I divide by 100. And that actually gives me the number 0.038. And that is just too small of a number. So out of all the numbers, yes, B and D look the most right, but those are called distractors. They are there to distract you and for you to choose it as the answer without actually doing the math. Once we actually went through and did the math and simplified, figuring